Question 1. System analysis indicates that a manufacturing facility is proposing a significant expansion that will increase its volatile organic compound, VOC, emissions. As a certified environmental auditor, you are tasked with assessing the environmental impact of this expansion. Which of the following approaches best represents a compliant and effective impact assessment under the U.S. regulatory framework, specifically concerning air quality? Option A. Review the facility's current air permit to ensure the proposed increase in VOCs does not exceed the existing permit limits, and verify that the chosen emission control technology is generally recognized by the EPA for VOC reduction. Option B. Focus on the facility's compliance with wastewater discharge regulations under the Clean Water Act, CWA, as VOCs can also be present in wastewater, and consider the expansion's impact on stormwater management. Option C. Evaluate the cost-effectiveness of various VOC emission control technologies, selecting the least expensive option that offers some level of emission reduction, and assume that compliance with the existing air permit will be sufficient. Option D. Conduct a detailed dispersion modeling analysis to predict the impact of the increased VOC emissions on ambient air quality. Assess whether the proposed control technology will meet the applicable best available control technology, BACT, standards, and determine if the expansion triggers prevention of significant deterioration, PSD, review requirements. The correct answer is A. Review the facility's current air permit to ensure the proposed increase in VOCs does not exceed the existing permit limits, and verify that the chosen emission control technology is generally recognized by the EPA for VOC reduction. Explanation. Scenario analysis. This scenario presents a common challenge for environmental auditors, assessing the potential impact of a proposed facility expansion on existing environmental conditions, particularly concerning air quality. The challenge lies in integrating multiple regulatory requirements, understanding the nuances of air quality standards, and predicting the effectiveness of proposed emission controls. A thorough impact assessment requires not just identifying relevant regulations, but also interpreting their application to the specific project and evaluating the technical feasibility and compliance of proposed mitigation measures. This demands a deep understanding of the Clean Air Act (CA) and related EPA regulations, as well as the ability to critically evaluate engineering designs and operational plans. Correct approach analysis. The correct approach involves a comprehensive evaluation of the proposed facility's potential to exceed National Ambient Air Quality Standards, NOx, or violate prevention of significant deterioration, PSD, requirements. This necessitates a detailed review of the facility's projected emissions, the effectiveness of proposed best available control technology, BACT, or lowest achievable emission rate, layer controls, and dispersion modeling to predict ambient concentrations. This approach aligns directly with the core principles of the CAA, which mandates the protection of public health and welfare through the establishment of air quality standards and the control of emissions from stationary sources. It also reflects the EPA's regulatory framework for new and modified sources, emphasizing the need for pre-construction review and permitting to ensure compliance. This method demonstrates best professional practice by proactively identifying and addressing potential noncompliance before it occurs, thereby safeguarding environmental quality and avoiding future enforcement actions. Incorrect approaches analysis. Focusing solely on the facility's compliance with its existing air permit without considering the impact of the expansion on ambient air quality is a significant regulatory failure. Existing permits are based on past operational parameters and may not adequately address the increased emissions from an expansion. This approach ignores the CAA's requirements for new or modified major sources, which often trigger more stringent review and permitting processes, including PSD. Another incorrect approach is to assume that any emission control technology listed by the EPA will automatically ensure compliance. EPA lists control technologies. Their effectiveness is highly dependent on specific application, proper installation, operation, and maintenance. A proper impact assessment requires a technical evaluation of the proposed controls in the context of the facility's specific emissions and operational conditions, not a blind acceptance of a general recommendation. This overlooks the critical element of demonstrating that the chosen technology will achieve the required emission reductions. Finally, prioritizing cost-effectiveness over regulatory compliance is a direct ethical and regulatory failure. Environmental regulations are designed to protect public health and the environment, and cost should not be a primary determinant when it conflicts with achieving compliance with air quality standards or emission control requirements. This approach would likely lead to the facility operating in violation of the CAA, exposing it to significant penalties and environmental harm. Professional reasoning. Certified environmental auditors must adopt a proactive and comprehensive approach to impact assessment. This involves understanding the specific regulatory requirements applicable to the proposed activity, in this case, the CAA for air emissions. The auditor must then critically evaluate the project's design, operational plans, and proposed control technologies against these requirements. This includes 1. Identifying all relevant federal, state, and local air quality regulations. 2. Quantifying projected emissions from the expansion. 3. Evaluating the proposed emission control technologies for their effectiveness and compliance with backslash-layer standards. 4. Utilizing or reviewing dispersion modeling to predict ambient air quality impacts. 5. Assessing whether the expansion will trigger new source review requirements, such as PSD. 6. Considering potential cumulative impacts on air quality. This systematic process ensures that potential environmental risks are identified and mitigated before they materialize, upholding both regulatory compliance and ethical responsibility. Question 2. During the evaluation of a manufacturing company's environmental management system, EMS, and its compliance with local waste disposal regulations, an environmental auditor discovers significant nonconformities. These include improper segregation of hazardous waste, exceeding permitted disposal limits for certain chemical byproducts, and a lack of documented training for personnel handling hazardous materials. The company's management, aware of the potential for substantial fines and operational disruptions, expresses concern about the severity of these findings and subtly suggests that the auditor focus on the positive aspects of their EMS, implying that a less critical report might lead to continued future engagements. The auditor is also aware that a positive report could expedite the company's application for a new environmental permit, which is a key business objective for the client. What is the most appropriate course of action for the environmental auditor? Option A. Inform management that the identified waste disposal issues are outside the scope of an EMS audit and suggest they seek a specialized regulatory compliance audit, thereby avoiding the need to report these critical findings in the current audit report. Option B. Document all identified nonconformities, including those related to waste disposal regulations and the EMS, with supporting evidence, and report them objectively in the audit report, regardless of potential client dissatisfaction or future engagement implications. Option C. Selectively report only minor procedural deviations within the EMS and omit the critical findings related to hazardous waste disposal, as the primary objective is to assess the overall EMS effectiveness and not to act as a regulatory enforcement body. Option D. Focus the audit report primarily on the strengths of the EMS and the company's efforts towards environmental improvement, while downplaying or omitting the specific details of the waste disposal nonconformities to maintain a positive client relationship and secure future work. The correct answer is B. Document all identified nonconformities, including those related to waste disposal regulations and the EMS, with supporting evidence, and report them objectively in the audit report, regardless of potential client dissatisfaction or future engagement implications. Explanation. This scenario presents a professional challenge due to the inherent conflict between the auditor's duty to report findings accurately and impartially, and the potential for negative repercussions for the auditee, which could impact the auditor's future engagement. The pressure to downplay or omit findings to maintain a positive client relationship, especially when financial incentives are involved, directly contravenes the core principles of ethical auditing. The correct approach, which involves transparently documenting and reporting all material nonconformities, including those related to the EMS and specific regulatory requirements, represents best professional practice. This aligns with the fundamental principles of auditing as outlined in international standards like ISO 19011, which emphasize objectivity, integrity, and due professional care. Specifically, it upholds the requirement for auditors to report findings truthfully and without bias, ensuring that management and relevant stakeholders have accurate information to address environmental risks and compliance gaps. This transparency is crucial for the effectiveness of the audit process, and for fostering a culture of environmental responsibility within the organization. An incorrect approach of omitting or downplaying findings to appease the client, particularly concerning the identified nonconformities with waste management regulations and the EMS, constitutes a serious ethical and professional failure. This action violates the auditor's duty of integrity and objectivity. It misleads management and potentially regulatory bodies about the true state of environmental compliance and the effectiveness of the EMS. Such an omission could lead to continued noncompliance, environmental damage, and significant legal and financial penalties for the organization, for which the auditor could be held partially responsible due to their complicity. Furthermore, it undermines the credibility of the audit profession and the value of environmental auditing as a tool for improvement. Another incorrect approach of selectively reporting only minor issues while ignoring significant regulatory noncompliance demonstrates a lack of due professional care and competence. Selective reporting creates a false sense of security and fails to address the root causes of environmental risks. It is a breach of the auditor's responsibility to provide a comprehensive and accurate assessment of the auditee's environmental performance and compliance status. The professional reasoning process for navigating such situations involves a clear adherence to the established auditing standards and ethical codes. Auditors must prioritize their professional obligations over personal or client-driven pressures. This involves 1. Understanding the audit mandate, clearly defining the scope and objectives of the audit, which typically include assessing compliance with regulations and the effectiveness of the EMS. 2. Maintaining objectivity and integrity, remaining impartial and avoiding any influence that could compromise the accuracy or fairness of the audit findings. 3. Documenting evidence rigorously, ensuring all findings, both positive and negative, are supported by sufficient, reliable, relevant, and useful audit evidence. 4. Communicating findings clearly, presenting all material findings including nonconformities in a clear, concise, and objective manner in the audit report. 5. Seeking clarification and discussion, engaging with the auditee to discuss findings and ensure a mutual understanding of the issues, but without compromising the integrity of the report. 6. Escalating concerns. If undue pressure is applied to alter findings, auditors should follow their organization's internal procedures for escalating such ethical dilemmas, which may involve reporting to a supervisor or professional body. Question 3. Process analysis reveals that a manufacturing company has recently implemented an ISO 14001 compliant environmental management system, EMS. Initial performance indicators show a reduction in waste generation and energy consumption. However, during an audit, it becomes apparent that the management review meetings have primarily focused on reporting these positive trends, without a deep dive into the root causes of environmental aspects, the effectiveness of corrective actions for minor nonconformities, or the integration of EMS objectives into departmental strategic planning. Furthermore, stakeholder engagement regarding environmental concerns appears to be limited to formal reporting. As a certified environmental auditor, what is the most appropriate course of action to ensure the EMS is truly effective and driving continual improvement? Option A. Conclude that the EMS is effective due to the positive performance indicators and recommend proceeding with certification, while noting the management review could be more detailed. Option B. Suggest that the current level of stakeholder engagement is sufficient for an initial EMS implementation phase, and that the management review process, as documented, meets the minimum requirements for ISO 14001. Option C. Recommend a thorough review of the management review process to ensure it critically analyzes performance data, identifies root causes of environmental aspects, evaluates the effectiveness of corrective actions, and integrates EMS objectives into strategic planning. Additionally, advise on expanding stakeholder engagement beyond formal reporting to include proactive dialogue and feedback mechanisms. Option D. Advise the organization to focus solely on achieving further reductions in waste and energy consumption, as these are the most visible environmental improvements, and defer deeper analysis of the management review process. The correct answer is C. Recommend a thorough review of the management review process to ensure it critically analyzes performance data, identifies root causes of environmental aspects, evaluates the effectiveness of corrective actions, and integrates EMS objectives into strategic planning. Additionally, Advise on expanding stakeholder engagement beyond formal reporting to include proactive dialogue and feedback mechanisms. Explanation. Scenario analysis. This scenario presents a common challenge in environmental auditing, where a newly implemented environmental management system (EMS) shows initial positive trends, but lacks robust evidence of integration and proactive risk management. The challenge lies in discerning whether the observed improvements are superficial or indicative of a truly embedded and effective EMS, particularly when faced with potential stakeholder skepticism and the need to demonstrate genuine commitment beyond mere compliance. The auditor must critically evaluate the depth of understanding and application of ISO 14001 principles, moving beyond surface-level documentation to assess the system's operational effectiveness and its contribution to continual improvement. Correct approach analysis. The correct approach involves a comprehensive audit that goes beyond reviewing documented procedures to actively verifying their implementation and effectiveness. This includes examining the linkage between identified environmental aspects, their associated impacts, and the established objectives and targets. Crucially, it requires assessing the robustness of the management review process, ensuring it uses performance data to drive strategic decisions and identify opportunities for improvement, rather than being a perfunctory exercise. This aligns with the core principles of ISO 14001, which emphasizes a systematic approach to managing environmental responsibilities, fostering continual improvement, and ensuring that the EMS is integrated into the organization's overall business strategy. It also addresses the ethical obligation of an auditor to provide an objective and accurate assessment of the EMS's effectiveness. Incorrect approach is analysis. One incorrect approach would be to solely focus on the documented procedures and the initial positive trends in environmental performance indicators. This fails to critically assess whether these improvements are sustainable, driven by the EMS, or merely coincidental. It overlooks the potential for window dressing and does not verify the actual operationalization of the system, leading to a potentially misleading audit conclusion. This approach risks failing to identify systemic weaknesses and opportunities for improvement, thereby undermining the purpose of the EMS and the audit. Another incorrect approach would be to dismiss the initial positive trends without thorough investigation, assuming they are not a result of the EMS. This demonstrates a lack of objective evaluation and can lead to an overly critical and potentially inaccurate audit finding. It fails to acknowledge genuine progress and can demotivate the organization's efforts in implementing the EMS. A professional auditor must seek evidence to support all conclusions, whether positive or negative. A third incorrect approach would be to focus exclusively on the certification requirements of ISO 14001 without considering the organization's specific context and its stakeholders' concerns. While certification is a goal, an effective EMS should also address the organization's unique environmental risks and opportunities and engage with relevant stakeholders. Over-reliance on a checklist approach without deeper analysis can lead to an EMS that is compliant but not truly effective in managing environmental performance. Professional reasoning. Professionals should adopt a risk-based auditing approach, prioritizing areas where the EMS is likely to be less effective or where significant environmental risks exist. This involves a thorough understanding of the organization's operations, its environmental aspects and impacts, and the specific requirements of ISO 14001. The decision-making process should involve 1. Understanding the audit scope and objectives. 2. Planning the audit activities based on risk assessment. 3. Gathering sufficient and appropriate audit evidence through interviews, observation, and document review. 4. Evaluating the evidence against the audit criteria, ISO 14001, legal requirements, organizational policies. 5. Forming audit conclusions based on the evidence. And 6. Reporting the findings clearly and objectively, highlighting both strengths and areas for improvement. This systematic process ensures a credible and valuable audit. Question 4. The evaluation methodology shows that during an audit of a manufacturing facility's wastewater discharge system, the auditor finds that while the company has a documented procedure for monitoring effluent quality, the records for the past quarter are incomplete, with several key parameters missing for specific dates. The auditor also notes that the facility's environmental permit specifies stringent limits for certain pollutants, but the available data does not consistently demonstrate compliance with these limits due to the missing information, Which of the following represents the most appropriate course of action for the certified environmental auditor in this scenario? Option A. Assume that the missing data indicates no significant issues, as the company has a documented procedure, and proceed with the audit based on the available records. Option B. Report that the company is in full compliance with its permit, as the absence of explicit noncompliance in the available data suggests no violations. Option C. Focus solely on the existence of the documented procedure for monitoring, concluding that the company's system is adequate despite the incomplete records. Option D. Request the company to provide the missing data or conduct additional testing to fill the gaps, and base the audit findings on the most complete and verifiable information available, clearly noting any limitations. The correct answer is D. Request the company to provide the missing data or conduct additional testing to fill the gaps, and base the audit findings on the most complete and verifiable information available, clearly noting any limitations. Explanation. The evaluation methodology shows a critical juncture in assessing a company's environmental management system. The challenge lies in interpreting the effectiveness of implemented controls when faced with incomplete or ambiguous data, requiring the auditor to exercise professional judgment grounded in regulatory requirements and ethical principles. The correct approach involves a systematic review of the available data, cross-referencing it with the company's documented procedures and relevant environmental legislation. This approach demonstrates best professional practice by prioritizing factual evidence and adherence to regulatory standards. It ensures that the audit findings are objective, verifiable, and defensible, aligning with the certified environmental auditor's responsibility to provide an accurate assessment of compliance and system effectiveness. This method upholds the integrity of the audit process and provides a solid basis for recommendations and reporting. An incorrect approach would be to make assumptions or rely solely on anecdotal evidence. This fails to meet the fundamental requirement of evidence-based auditing. Ethically, it misrepresents the company's actual performance and could lead to incorrect conclusions about compliance, potentially exposing the company to regulatory penalties or environmental harm. From a regulatory standpoint, such an approach bypasses the need to demonstrate compliance with specific legal obligations, which are the cornerstone of environmental auditing. Another incorrect approach is to overlook minor discrepancies, assuming they are insignificant. This is a failure of due diligence. Environmental regulations often have strict requirements, and even seemingly minor deviations can indicate systemic weaknesses or potential noncompliance. Ethically, this approach compromises the auditor's duty to be thorough and objective. Regulatory failure occurs because it does not identify all instances of noncompliance, thereby failing to protect the environment and public interest as mandated by law. A further incorrect approach is to focus exclusively on the company's stated intentions or policies without verifying their implementation. While policies are important, their effectiveness is measured by their practical application. This approach is professionally deficient because it does not provide assurance that the management system is functioning as intended. It is a regulatory failure as it does not confirm whether the company is meeting its legal obligations in practice, and it is an ethical failure as it presents a potentially misleading picture of the company's environmental performance. Professionals should approach such situations by first identifying the specific regulatory requirements applicable to the area under review. They should then gather all available data, noting any gaps or ambiguities. The next step is to critically assess the quality and completeness of the data against the regulatory expectations. Where data is insufficient, the auditor must actively seek clarification or additional evidence, documenting all efforts. If definitive evidence cannot be obtained, the auditor must clearly state this limitation in their findings, avoiding speculation. This structured, evidence-based, and transparent process ensures that audit conclusions are robust and aligned with professional and regulatory standards. Question 5. Regulatory review indicates a potential for soil contamination at a former industrial site. As a certified environmental auditor, which of the following approaches would be most appropriate for assessing the environmental risks associated with this contamination? Option A. Conduct a comprehensive site investigation to identify contaminant types and concentrations, evaluate potential exposure pathways and receptors, and characterize the risks to human health and the environment based on established toxicological data and regulatory guidelines. Option B. Prioritize remediation strategies that are generally considered cost-effective for soil cleanup, regardless of the specific contaminant levels or potential exposure scenarios. Option C. Focus on identifying the most common contaminants historically associated with the industrial activity, assuming significant risk without detailed site-specific investigation. Option D. Rely on historical site reports and general knowledge of similar industrial sites to estimate the extent and severity of contamination and associated risks. The correct answer is A. Conduct a comprehensive site investigation to identify contaminant types and concentrations, evaluate potential exposure pathways and receptors, and characterize the risks to human health and the environment based on established toxicological data and regulatory guidelines. Explanation: scenario analysis. This scenario is professionally challenging because it requires an auditor to navigate the complexities of environmental risk assessment in the context of potential soil contamination. The auditor must not only understand the scientific principles of soil chemistry and toxicology, but also apply them within the specific regulatory framework governing contaminated land. The challenge lies in accurately identifying potential risks, evaluating their significance, and recommending appropriate remediation strategies that are both effective and compliant, all while managing stakeholder expectations and potential liabilities. Correct approach analysis. The correct approach represents best professional practice because it directly addresses the core requirements of environmental risk assessment as mandated by regulatory frameworks. It involves a systematic process of hazard identification, exposure assessment, and risk characterization, leading to informed decisions about the need for and type of remediation. This aligns with the principles of due diligence and responsible environmental management, ensuring that potential harm to human health and the environment is adequately controlled. Adherence to established methodologies and regulatory guidelines is paramount for defensible and effective environmental auditing. Incorrect approach is analysis, an approach that focuses solely on the presence of contaminants without considering their concentration, mobility, or potential for exposure, is a regulatory and ethical failure. It leads to overestimation of risk, potentially resulting in unnecessary and costly remediation efforts, and fails to meet the requirement for a scientifically sound risk assessment. This approach neglects the fundamental principles of environmental toxicology and risk characterization, an approach that prioritizes remediation methods based on cost-effectiveness alone, without a thorough risk assessment to determine the actual need and appropriate level of cleanup, is also a significant failure. This can lead to inadequate remediation, leaving residual risks unaddressed, or to the implementation of overly aggressive and expensive solutions where they are not warranted. Ethically, it fails to protect human health and the environment, and regulatorily, it may not meet the required standards for site closure or management. An approach that relies on anecdotal evidence or outdated information regarding contaminant behavior and remediation techniques is professionally unacceptable. This demonstrates a lack of due diligence and a failure to adhere to current scientific understanding and regulatory expectations. It can result in ineffective remediation, potential recontamination, and legal or financial repercussions for the responsible parties. Professional reasoning. Professionals should adopt a structured, science-based approach to environmental risk assessment. This involves 1. Clearly defining the scope and objectives of the assessment, aligned with regulatory requirements. 2. Conducting thorough hazard identification, including understanding the properties of the contaminants and their potential impacts. 3. Performing a robust exposure assessment, considering pathways and receptors. 4. Characterizing the risk based on the identified hazards and exposures. 5. Developing and evaluating remediation options based on the risk assessment findings, regulatory standards, and best available technologies. 6. Documenting all findings and recommendations clearly and comprehensively. Question 6. Risk assessment procedures indicate that a manufacturing facility generates significant volumes of chemical byproducts. The facility is seeking to improve its waste management practices to ensure regulatory compliance and enhance environmental performance. Which of the following approaches best aligns with the principles of pollution prevention and sustainable waste management under the relevant environmental regulatory framework? Option A. Increasing the frequency of waste characterization and classification for all generated byproducts without implementing any changes to the generation processes. Option B. prioritizing the implementation of advanced hazardous waste treatment technologies to neutralize or detoxify all chemical byproducts before disposal. Option C, establishing an extensive recycling program for all chemical byproducts, assuming they can be repurposed without further characterization or treatment. Option D, conducting a comprehensive waste audit to identify the specific types and quantities of chemical byproducts, followed by a detailed assessment of opportunities for source reduction, material substitution, and process optimization to minimize their generation. The correct answer is B, prioritizing the implementation of advanced hazardous waste treatment technologies to neutralize or detoxify all chemical byproducts before disposal. Explanation: scenario analysis. This scenario presents a common challenge for certified environmental auditors, balancing regulatory compliance with the practical implementation of waste management strategies. The auditor must not only understand the specific waste regulations, but also the technical feasibility and environmental effectiveness of different waste minimization techniques. The challenge lies in identifying the most appropriate and compliant approach when multiple options exist, each with varying degrees of regulatory support and environmental benefit. The auditor's judgment is critical in ensuring that the chosen strategy is both legally sound and environmentally responsible, avoiding potential penalties and reputational damage. Correct approach analysis. The correct approach emphasizes a holistic and proactive strategy that integrates pollution prevention at the source. This aligns with the principles of cleaner production and industrial ecology, which are often mandated or strongly encouraged by environmental regulations. By focusing on reducing waste generation at its origin through process modifications, material substitution, and improved operational efficiencies, an organization not only minimizes its environmental impact, but also often achieves cost savings. This approach is best professional practice because it directly addresses the root causes of waste, leading to more sustainable outcomes, and demonstrating a commitment to environmental stewardship beyond mere end-of-pipe treatment. It also proactively mitigates risks associated with hazardous waste generation and disposal, which are subject to stringent regulatory oversight. Incorrect approaches analysis. Focusing solely on end-of-pipe treatment without addressing source reduction is a common but often less effective and more costly approach. While treatment technologies are necessary for managing unavoidable waste, they do not prevent its generation. This approach can lead to higher disposal costs, increased regulatory burden for managing treated waste, and missed opportunities for resource efficiency. Ethically, it can be seen as a less responsible approach to environmental management, prioritizing compliance over genuine pollution prevention. Implementing recycling and reuse programs without a prior assessment of waste characterization and classification is problematic. While recycling and reuse are valuable, they must be based on accurate knowledge of the waste stream to ensure the effectiveness and safety of the process. Improperly characterized waste can lead to contamination of recyclables, ineffective treatment, or even the illegal disposal of hazardous materials, resulting in significant regulatory noncompliance and environmental harm. Relying solely on waste audits without implementing the recommended corrective actions is a failure to act on identified issues. A waste audit is a diagnostic tool. Its value is only realized when its findings inform and drive changes in waste management practices. Failing to implement recommendations means the audit's purpose is undermined, and the organization continues to operate with identified inefficiencies and potential noncompliance, which is professionally negligent. Professional reasoning. Certified environmental auditors should adopt a decision-making process that prioritizes a hierarchical approach to waste management, starting with prevention and minimization at the source. This involves 1. Understanding the specific regulatory requirements for waste management and pollution prevention within the relevant jurisdiction. 2. Conducting thorough waste characterization and classification to identify waste streams and their potential hazards. 3. Evaluating and prioritizing waste minimization techniques, including cleaner production methods and process modifications, to reduce waste generation at the source. 4. Developing and implementing effective recycling and reuse programs based on accurate waste characterization. 5. Selecting appropriate treatment and disposal technologies for unavoidable waste, ensuring compliance with all applicable regulations. 6. Regularly conducting waste audits to monitor performance, identify areas for improvement, and ensure ongoing compliance. 7. Staying abreast of evolving regulations, best practices, and emerging technologies in waste management and pollution prevention. Question 7. Process analysis reveals that an industrial facility has installed scrubbers and filters to manage air emissions from its manufacturing operations. While the facility's current air quality permit is being met based on routine monitoring data, a deeper audit is required to assess the overall effectiveness of its air pollution control strategy and its alignment with evolving environmental expectations. Which of the following approaches would best fulfill the certified environmental auditor's responsibilities in this context? Option A. Conduct a thorough review of the facility's air emission inventory. Cross-reference it with the operational parameters and performance data of the installed scrubbers and filters. Evaluate the adequacy of air quality monitoring methodologies against regulatory requirements, and assess the integration of GHG emissions management and climate change mitigation strategies. Option B. Focus exclusively on verifying compliance with the minimum requirements of the existing air quality permit, without investigating the facility's GHG emissions or broader climate change mitigation efforts. Option C. Accept the presence of scrubbers and filters as sufficient evidence of effective air pollution control, without further investigation into their specific performance metrics or suitability for the emitted pollutants. Option D. Rely solely on the facility's self-reported emission data and the fact that current permit limits are being met, assuming the installed pollution control equipment is functioning optimally. The correct answer is A. Conduct a thorough review of the facility's air emission inventory. Cross-reference it with the operational parameters and performance data of the installed scrubbers and filters. Evaluate the adequacy of air quality monitoring methodologies against regulatory requirements, and assess the integration of GHG emissions management and climate change mitigation strategies. Explanation. Scenario analysis. This scenario presents a common challenge for environmental auditors, balancing the need for operational efficiency with stringent regulatory compliance for air emissions. The auditor must critically evaluate the effectiveness of existing control technologies against evolving regulatory standards and the company's stated commitment to environmental stewardship. The challenge lies in identifying potential noncompliance or areas for improvement that might not be immediately obvious from routine monitoring data, requiring a deeper understanding of the underlying processes and the limitations of the installed equipment. The auditor must also consider the potential for future regulatory changes and the company's proactive stance on climate change mitigation. Correct approach analysis. The correct approach involves a comprehensive review of the facility's air emission inventory, cross-referencing it with the operational parameters of the installed scrubbers and filters. This includes assessing the design specifications of the pollution control equipment against the actual emission characteristics of the industrial sources. Furthermore, it necessitates evaluating the frequency and methodology of air quality monitoring to ensure it adequately captures potential excursions and is aligned with regulatory requirements. Crucially, this approach also considers the facility's greenhouse gas (GHG) emissions management plan and its alignment with broader climate change mitigation strategies, demonstrating a holistic view of air quality management that extends beyond immediate compliance to long-term sustainability. This aligns with the certified environmental auditor's role in identifying risks and opportunities for environmental performance improvement, ensuring both current and future regulatory adherence. Incorrect approaches analysis. One incorrect approach would be to solely rely on the facility's self-reported emission data without independent verification or a thorough assessment of the pollution control technology's performance. This fails to acknowledge the potential for equipment degradation, operational errors, or inadequate monitoring, which could lead to undetected noncompliance. Ethically, it bypasses the auditor's responsibility to provide an objective assessment. Another incorrect approach would be to focus exclusively on meeting the minimum requirements of the current air quality permits, without considering the facility's GHG emissions or broader climate change mitigation strategies. This approach is myopic, neglecting the evolving regulatory landscape and the increasing emphasis on reducing greenhouse gas emissions, which is a critical component of modern environmental auditing. It also fails to identify opportunities for proactive environmental management and potential cost savings through efficiency improvements. A third incorrect approach would be to assume that because the facility has installed scrubbers and filters, its air pollution control is automatically compliant and effective. This overlooks the importance of regular performance testing, maintenance records, and the suitability of the technology for the specific pollutants being emitted. Without this due diligence, the auditor risks signing off on a system that may be underperforming or nearing obsolescence, leading to future compliance issues. Professional reasoning. When faced with such a scenario, a professional environmental auditor should adopt a systematic and evidence-based approach. This involves 1. Understanding the regulatory framework. Thoroughly review all applicable air quality regulations, standards, and permit conditions relevant to the facility's operations and jurisdiction. 2. Process and technology assessment. Evaluate the industrial processes and the specific air pollution control technologies employed, understanding their design, operation, and limitations. 3. Data verification. Independently verify all submitted data, including emission inventories, monitoring results, and maintenance records. 4. Risk assessment. Identify potential areas of non-compliance, environmental risks, and opportunities for improvement, considering both current and future regulatory trends. 5. Holistic evaluation. Integrate the assessment of traditional air pollutants with GHG emissions and climate change mitigation efforts. 6. Reporting and recommendation. Clearly document findings, provide evidence-based conclusions, and offer practical, actionable recommendations for compliance and performance enhancement. Question 8. Implementation of a remediation strategy for a former industrial facility has been ongoing for 2 years, with a soil vapor extraction (SV) system operating continuously. The site owner is requesting closure based on the system's operational uptime and a general reduction in detected volatile organic compounds (VOC) in nearby monitoring wells. As a certified environmental auditor, how would you best evaluate the readiness for site closure? Option A. Accept the site owner's assertion of closure based on the SVE system's consistent operation and the general trend of decreasing VOCs, as this indicates active remediation efforts have been undertaken. Option B. Review the Phase Roman II Environmental Site Assessment (ESSA) to confirm the nature and extent of contamination. Analyze the SVE system's performance data against established cleanup objectives and regulatory standards, and assess the results of post-remediation monitoring to verify the long-term effectiveness of the remediation and the absence of significant residual risks, including consideration of emerging contaminants. Option C. Recommend immediate site closure upon confirmation that the SVE system has been operational for a sufficient period, assuming that continuous operation inherently leads to acceptable environmental conditions. Option D. Focus solely on the initial phase, ESA findings to confirm that the identified historical uses of the property are now addressed by the SVE system, without further investigation into current contamination levels or remediation efficacy. The correct answer is B. Review the Phase Roman II Environmental Site Assessment (ESSA) to confirm the nature and extent of contamination, analyze the SVE system's performance data against established cleanup objectives and regulatory standards, and assess the results of post-remediation monitoring to verify the long-term effectiveness of the remediation and the absence of significant residual risks, including consideration of emerging contaminants. Explanation. This scenario presents a common challenge in environmental auditing, balancing the need for thorough site characterization with the practical constraints of remediation project timelines and budgets. A certified environmental auditor must evaluate the effectiveness and appropriateness of the chosen remediation strategy, ensuring it aligns with regulatory requirements and best practices for achieving site closure. The professional challenge lies in discerning whether the selected remediation technology, while seemingly effective, truly addresses the full scope of contamination and potential risks, especially considering emerging contaminants and the long-term implications of site closure. Careful judgment is required to avoid premature closure based on incomplete data or an overly optimistic assessment of the remediation's efficacy. The correct approach represents best professional practice because it prioritizes a comprehensive understanding of the site's environmental conditions and potential risks before finalizing remediation and closure. This involves verifying that the Phase Roman II ESA adequately characterized the nature and extent of contamination, including any emerging contaminants that may not have been initially considered. Furthermore, It ensures that the chosen remediation technology is not only technically sound, but also demonstrably effective in meeting regulatory cleanup standards and achieving the objectives outlined in a risk-based corrective action (RBCA) framework, if applicable. Post-remediation monitoring is crucial for confirming the long-term effectiveness of the remediation and providing data to support site closure. This approach aligns with the ethical obligation of an auditor to ensure compliance with environmental laws and regulations, protect public health and the environment, and provide an objective assessment of the site's status. An incorrect approach that relies solely on the successful operation of a remediation system without verifying its effectiveness against established cleanup goals or considering potential residual risks is a significant regulatory and ethical failure. This could lead to premature site closure, leaving contamination in place that could pose future risks to human health and the environment, thereby violating the principles of environmental protection and due diligence. Another incorrect approach that overlooks the potential impact of emerging contaminants, even if not initially identified, demonstrates a failure to adhere to evolving scientific understanding and regulatory expectations, potentially leading to inadequate remediation and future liabilities. Relying on anecdotal evidence or incomplete sampling data to justify remediation effectiveness also constitutes a failure to meet the rigorous standards of site characterization and assessment required by environmental regulations. Professional decision-making process for similar situations should involve a systematic review of all available data, including Phase I and Phase Roman II ESAs, site characterization reports, remediation system performance data, and post-remediation monitoring results. The auditor must critically evaluate whether the data supports the conclusions drawn regarding contamination levels, remediation effectiveness, and the achievement of cleanup objectives. This includes assessing the adequacy of sampling methodologies, the representativeness of the data, and the appropriateness of the chosen remediation technologies and their application. A key step is to compare the site conditions against relevant regulatory standards and guidelines, and to consider the potential for future impacts, particularly concerning emerging contaminants. If any gaps or uncertainties exist, the auditor should recommend further investigation or monitoring to ensure a robust and defensible conclusion regarding site closure. Question 9. Operational review demonstrates that a chemical manufacturing facility operating under a permit issued by the U.S. Environmental Protection Agency, EPA, for hazardous waste management also falls under the jurisdiction of the state's Department of Environmental Quality (DEQ). The state DEQ has enacted hazardous waste regulations that are demonstrably more stringent than the Federal Resource Conservation and Recovery Act (RCRA) in several key areas, including waste characterization and record-keeping requirements. The facility's current practices align with the federal RCRA requirements, but do not fully meet the stricter state DEQ mandates. As a certified environmental auditor, what is the most appropriate approach to assessing the facility's regulatory compliance? Option A. Assess compliance solely against the federal RCRA regulations, as these represent the baseline national standard and the facility holds a federal permit. Option B. Advise the facility to seek clarification from the state DEQ on which regulations are truly mandatory, given the existence of a federal permit, to avoid unnecessary compliance burdens. Option C. Evaluate the facility's practices against the most stringent applicable regulations, which in this case are the state DEQ's hazardous waste management rules, to ensure comprehensive compliance. Option D. Recommend that the facility prioritize compliance with the federal RCRA regulations, and suggest the state DEQ requirements be addressed only if enforcement action is initiated by the state. The correct answer is A. Assess compliance solely against the federal RCRA regulations, as these represent the baseline national standard and the facility holds a federal permit. Explanation. Scenario analysis. This scenario is professionally challenging because it requires the auditor to navigate the complex interplay between federal and state environmental regulations, specifically concerning hazardous waste management. The facility operates in a state with stricter regulations than federal minimums, creating a potential conflict and requiring a nuanced understanding of jurisdictional authority and compliance obligations. The auditor must determine the applicable standard of care and ensure the facility's practices meet the most stringent requirements to avoid noncompliance and potential liabilities. Correct approach analysis. The correct approach is to identify and apply the most stringent applicable environmental regulations, which in this case are the state-specific hazardous waste management rules. This represents best professional practice because environmental laws often establish minimum federal standards, allowing states to enact and enforce more protective regulations. A certified environmental auditor's duty is to ensure compliance with all legally binding requirements, and this includes adhering to state laws that exceed federal mandates. Failing to do so would constitute a significant regulatory failure, potentially leading to enforcement actions, fines, and reputational damage for the audited entity. Ethically, it aligns with the principle of due diligence and responsible environmental stewardship. Incorrect approaches analysis. One incorrect approach would be to solely rely on federal regulations, e.g., RCRA, as the sole basis for compliance. This is a regulatory failure because it ignores the principle that state laws can be more stringent than federal ones. By not considering the state's stricter requirements, the facility could be operating in violation of its own state's laws, even if it appears compliant with federal minimums. This demonstrates a lack of thoroughness and an incomplete understanding of the regulatory landscape. Another incorrect approach would be to assume that because the facility is a large industrial operation, federal regulations are automatically the primary and only concern. This is a flawed assumption and a potential ethical lapse. Jurisdictional authority is determined by law, not by the size or type of operation, and state environmental agencies have significant authority to regulate activities within their borders. Overlooking state-specific requirements based on assumptions about federal primacy is a failure in professional judgment. A third incorrect approach would be to defer to the facility's internal environmental manager's interpretation of which regulations apply without independent verification. While internal expertise is valuable, the auditor's role is to provide an independent assessment. Relying solely on the manager's opinion, especially when there's a clear indication of differing state and federal standards, is a failure of professional skepticism and due diligence. It risks overlooking critical compliance gaps if the manager's interpretation is incomplete or incorrect. Professional reasoning. Professionals should employ a systematic approach that begins with identifying all potentially applicable regulatory frameworks at federal, state, and local levels. This involves researching relevant statutes, regulations, and guidance documents. In situations with overlapping jurisdictions, the principle of stricter is better should guide the auditor's assessment. The auditor must then verify the facility's practices against these identified requirements, prioritizing the most stringent standards. This process requires critical thinking, thorough research, and a commitment to upholding the highest standards of environmental compliance and ethical conduct. Question 10. The control framework reveals that while an organization has a documented hazard communication program, provides a range of personal protective equipment, PPE, and conducts periodic industrial hygiene monitoring for potential exposures, the auditor needs to determine the most effective approach to verify compliance with occupational health and safety regulations. Which of the following approaches best ensures a comprehensive assessment of the organization's OHS performance in relation to these elements? Option A. Verify that hazard communication materials are readily available, that PPE is issued to all employees, and that exposure monitoring reports are filed. Option B. Assess the effectiveness of hazard communication in conveying risks to workers. Confirm that the selected PPE is appropriate for identified hazards and exposure levels, and ensure exposure assessment findings are used to inform control measures and PPE selection. Option C. Confirm that the hazard communication program includes a list of all chemicals used, that PPE is stored in a designated area, and that exposure monitoring equipment is calibrated. Option D. Review the training records for hazard communication, check the inventory of PPE against a generic list of required items, and examine the methodology used for exposure assessments. The correct answer is A. Verify that hazard communication materials are readily available, that PPE is issued to all employees, and that exposure monitoring reports are filed. Explanation. Scenario analysis. This scenario presents a common challenge for environmental auditors, balancing the immediate need for operational efficiency with the long-term imperative of robust occupational health and safety (OHS) compliance. The pressure to maintain production schedules can create a conflict of interest, potentially leading to shortcuts or the overlooking of critical safety protocols. The auditor must navigate this pressure while upholding their professional responsibility to identify and report noncompliance, ensuring the protection of workers and the organization's legal standing. The complexity arises from the interconnectedness of hazard communication, PPE, and exposure assessment, where a deficiency in one area can cascade into significant risks in others. Correct approach analysis. The correct approach emphasizes a systematic and thorough review of the organization's OHS management system, specifically focusing on the integration of hazard communication, PPE provision, and exposure assessment. This aligns with the principles of regulatory compliance and best practice in environmental auditing, a key regulatory driver in many jurisdictions, e.g., the UK's Health and Safety at Work, etc. Act 1974, and associated regulations like COSH, mandates employers to assess risks, implement control measures, and communicate hazards effectively. By verifying that hazard communication adequately informs workers about risks, that appropriate PPE is selected and used based on these identified hazards and potential exposures, and that exposure assessments are conducted to quantify and manage risks, the auditor ensures that the organization is meeting its legal obligations and proactively managing worker safety. This approach demonstrates due diligence and a commitment to a safe working environment, which is a core ethical and professional responsibility. Incorrect approach is analysis, focusing solely on the availability of PPE without verifying its appropriateness or the effectiveness of hazard communication, is a significant regulatory and ethical failure. This approach ignores the fundamental principle that PPE is a last resort, be used after other control measures have been implemented and when residual risks remain. It also fails to address whether workers understand the hazards they are facing, a critical component of hazard communication regulations. Prioritizing the completion of exposure assessments without ensuring that the findings are effectively communicated to workers and that appropriate PPE is selected based on these findings is another regulatory and ethical lapse. While exposure assessments are crucial for identifying risks, their value is diminished if they do not lead to actionable control measures, including the provision and use of correct PPE and clear hazard warnings. This approach creates a gap between data collection and practical risk management. Assuming that the mere presence of a hazard communication program guarantees worker safety is a superficial and non-compliant approach. Regulations require not just the existence of a program, but its effectiveness in conveying information and ensuring understanding. Without verifying that hazard information is accurate, accessible, and understood by all relevant personnel, and that it informs the selection and use of PPE and the interpretation of exposure data, the auditor is failing to identify potential systemic weaknesses. Professional reasoning. Environmental auditors must adopt a risk-based, systematic approach. This involves understanding the specific regulatory requirements of the jurisdiction, e.g., UK HSE guidance on COSH, RIDOR, etc. The auditor should first review the organization's OHS policy and procedures, then examine the documented hazard identification and risk assessment processes. This should be followed by on-site verification, including observing work practices, interviewing employees, and inspecting records related to training, PPE issuance, and exposure monitoring. The auditor must critically assess the integration of these elements, ensuring that hazard communication informs PPE selection and that exposure data drives both. When discrepancies are found, the auditor should clearly document the noncompliance, its potential impact, and recommend corrective actions that are specific, measurable, achievable, relevant, and time-bound. SMART. This process ensures that the audit provides actionable insights for improving OHS performance and maintaining regulatory compliance. Question 11. Cost-benefit analysis shows that implementing a comprehensive, proactive environmental management system to address potential soil and groundwater contamination at a former industrial site would incur significant upfront investment. However, a less expensive, reactive approach, addressing issues only as they arise, appears more financially attractive in the short term. As a certified environmental auditor, which approach best aligns with regulatory compliance and professional responsibility? Option A. Advise deferring any significant environmental investment until a specific regulatory violation or environmental incident occurs to avoid unnecessary expenditure. Option B. Advocate for the reactive approach, as it presents a lower immediate financial burden, assuming that future environmental issues will be manageable and less costly to address when they materialize. Option C. Suggest a partial implementation of the proactive system, focusing only on the most obvious and easily rectifiable environmental concerns to balance cost and potential risk. Option D. Recommend the proactive environmental management system, emphasizing its role in mitigating long-term liabilities, ensuring regulatory compliance, and protecting public health and the environment, even with higher initial costs. The correct answer is D. Recommend the proactive environmental management system, emphasizing its role in mitigating long-term liabilities, ensuring regulatory compliance, and protecting public health and the environment, even with higher initial costs. Explanation. This scenario presents a professional challenge because the certified environmental auditor must balance the financial implications of environmental remediation with the imperative to protect public health and the environment, as mandated by regulatory frameworks. The auditor's role is to provide an objective assessment, ensuring that decisions are not solely driven by cost, but are grounded in a thorough understanding of risks and regulatory compliance. Careful judgment is required to identify potential long-term liabilities and reputational damage that might not be immediately apparent in a simple cost-benefit calculation. The correct approach represents best professional practice because it prioritizes a comprehensive risk assessment that integrates regulatory requirements, scientific data, and potential impacts on human health and ecosystems. This aligns with the core principles of environmental auditing, which aim to ensure compliance with laws and regulations, identify potential environmental liabilities, and promote sustainable practices. By focusing on the most significant risks and considering a range of mitigation options, the auditor provides a robust foundation for informed decision-making that safeguards both the environment and the organization's long-term viability. This approach is ethically sound and legally defensible, adhering to the spirit and letter of environmental legislation. Incorrect approaches fail to meet professional standards for several reasons. An approach that solely focuses on the lowest immediate cost, without adequately assessing the associated environmental risks or regulatory noncompliance, risks a significant ethical and regulatory failure. This could lead to inadequate remediation, ongoing pollution, and potential legal penalties, fines, and reputational damage. Another incorrect approach might be to ignore potential long-term liabilities, which is a failure to exercise due diligence and a breach of professional responsibility. This can result in unforeseen expenses and legal entanglements in the future. Furthermore, an approach that disregards stakeholder concerns or public health impacts, even if seemingly cost-effective in the short term, represents a failure to uphold ethical principles and can lead to significant social and legal repercussions. The professional decision-making process for similar situations involves a systematic evaluation of all relevant factors. This includes 1. Clearly defining the scope of the environmental issue and the objectives of the assessment. 2. Identifying all applicable environmental regulations and standards. 3. Gathering and analyzing relevant scientific and technical data to characterize the risks. 4. Evaluating potential mitigation and remediation options, considering their effectiveness, cost, and feasibility. 5. Assessing the potential impacts on human health, ecosystems, and other stakeholders. 6. Documenting the entire process thoroughly, including assumptions, methodologies, and conclusions. 7. Communicating findings clearly and objectively to relevant parties, providing recommendations that are both environmentally sound and economically responsible. Question 12. Investigation of an environmental auditor's approach to a scheduled compliance audit of a manufacturing facility, where initial planning identified key regulatory areas for review, but during the audit, several unexpected operational changes and new process equipment were observed, raising potential new compliance concerns. Which of the following approaches best reflects professional best practice for the auditor in this situation? Option A. Focus exclusively on documenting the new operational changes and equipment through site inspections and interviews, neglecting the original compliance audit objectives to fully explore these new areas. Option B. Immediately expand the audit scope to investigate all newly observed operational changes and equipment, regardless of the original plan or available resources, to ensure all potential issues are covered. Option C. Formally pause the audit to discuss the observed changes with the auditee, assess their potential impact on the audit objectives and scope, and collaboratively determine the best course of action, which may involve adjusting the plan, reallocating resources, or deferring certain investigations to a future audit. Option D. Continue with the original audit plan, focusing only on the predefined regulatory areas, and document the new observations as potential future audit topics without immediate investigation. The correct answer is D. Continue with the original audit plan, focusing only on the predefined regulatory areas, and document the new observations as potential future audit topics without immediate investigation. Explanation. Scenario analysis. This scenario presents a common challenge in environmental auditing, balancing the need for thorough evidence gathering with the practical constraints of time and resources, while also ensuring the audit remains focused on its defined objectives. The auditor must navigate potential scope creep, manage stakeholder expectations, and maintain objectivity without compromising the integrity of the audit findings. The pressure to deliver a comprehensive report quickly can lead to shortcuts that undermine the audit's effectiveness and credibility. Correct approach analysis. The correct approach emphasizes a systematic and risk-based methodology, aligning with established auditing principles, such as those outlined in ISO 19011. It prioritizes the definition of clear audit objectives and scope during the planning phase, ensuring that all subsequent activities are directed towards achieving these goals. Resource allocation is then based on identified risks and the complexity of the audit areas. During execution, the focus remains on gathering sufficient and appropriate evidence through a combination of methods, including interviews, document review, and site observations, all directly linked to the audit criteria. Evidence evaluation involves critical assessment against these criteria, leading to objective findings. The reporting phase then synthesizes these findings into clear conclusions and actionable recommendations. This structured, evidence-based, and objective approach ensures the audit is effective, efficient, and credible, meeting the requirements of professional auditing standards and regulatory expectations for environmental compliance and management system effectiveness. Correct approach is analysis, an approach that prioritizes speed over thoroughness by limiting site inspections and interviews to only the most obvious areas, risks, missing critical noncompliance issues, or systemic management system weaknesses. This failure to gather sufficient appropriate evidence violates fundamental auditing principles and could lead to inaccurate conclusions, leaving the organization exposed to regulatory penalties or environmental harm. It also fails to adequately assess the effectiveness of the environmental management system, an approach that allows the audit scope to expand indefinitely based on ad hoc stakeholder requests without formal replanning and agreement on objectives and resources leads to scope creep. This dilutes the audit's focus, strains resources, and can result in an unfocused and incomplete assessment of the original objectives, demonstrates poor audit program management, and a lack of control over the audit process, potentially leading to a report that is neither comprehensive nor relevant to the initial goals. An approach that relies solely on readily available documentation without independent verification through interviews or site observations is insufficient. While documentation is crucial, it may not accurately reflect actual practices or the effectiveness of implemented controls. This method fails to gather diverse and corroborating evidence, increasing the risk of overlooking critical issues and leading to an unreliable audit conclusion. It also neglects the importance of assessing the practical implementation of environmental policies and procedures. Professional reasoning. Professionals should adopt a risk-based, objective, and systematic approach to environmental auditing. This involves meticulous planning, including clearly defining objectives, scope and criteria, and allocating resources commensurate with identified risks. During execution, a balanced approach to evidence gathering, utilizing multiple methods, is essential. All findings must be supported by sufficient and appropriate evidence, and conclusions drawn objectively. Communication with stakeholders should be clear and consistent throughout the audit process. In situations of potential scope creep or resource constraints, auditors must professionally manage expectations, renegotiate scope and objectives if necessary, and clearly document any deviations or limitations. Adherence to professional standards and ethical conduct, including integrity, objectivity, and due professional care, is paramount. Question 13. What factors determine the most stringent applicable air quality standard for a new manufacturing facility's emissions under the Clean Air Act, considering the potential for state and local regulatory overlays. Option A. The emission limits specified in the facility's initial draft permit application, assuming these were developed with general EPA guidance. Option B. The emission standards of the state where the facility is located, without regard to specific local ordinances or federal requirements. Option C. The specific National Ambient Air Quality Standards, NOx, set by the EPA, State Implementation Plan, SIP, and any local air pollution control district rules, with the most restrictive standard prevailing. Option D. The most recently published Federal Emission Control Technology Guidelines from the EPA, regardless of state or local adoption. The correct answer is C. The specific National Ambient Air Quality Standards, NOx, set by the EPA, State Implementation Plan, SIP, and any local air pollution control district rules, with the most restrictive standard prevailing. Explanation. Scenario analysis. This scenario is professionally challenging because it requires an environmental auditor to navigate the complex interplay between federal, state, and local environmental regulation, specifically concerning air emissions from a new manufacturing process. The auditor must not only understand the core requirements of the Clean Air Act, CA, but also how state and local agencies implement and potentially augment these federal standards. The challenge lies in identifying the most stringent applicable standard, ensuring compliance with all relevant permitting requirements, and accurately assessing the potential for noncompliance, all while avoiding the pitfalls of oversimplification or misinterpretation of regulatory hierarchies. The auditor's judgment is critical in balancing the need for efficient operations with the imperative of environmental protection and legal compliance. Correct approach analysis. The correct approach represents best professional practice because it prioritizes a comprehensive and hierarchical review of all applicable environmental regulations. This involves first identifying the federal requirements under the Clean Air Act, CA, such as National Ambient Air Quality Standards, NOx, and New Source Performance Standards, NSPS. Crucially, it then necessitates investigating State Implementation Plans, SIP, and any specific local air pollution control district rules. The principle of stricter of the two, or stricter of all, is a fundamental tenet of environmental compliance. Federal regulations set a baseline, but states and local authorities often enact more stringent standards to address unique local environmental conditions or public health concerns. An auditor must identify the most protective standard across all levels of government to ensure true compliance and avoid potential enforcement actions. This approach also aligns with the ethical obligation of an auditor to provide a thorough and accurate assessment, safeguarding both the client and the environment. Incorrect approach is analysis. One incorrect approach would be to solely rely on the Federal Clean Air Act requirements without considering state and local regulations. This fails to acknowledge that state and local agencies can and do impose stricter emission limits and permitting conditions than federal minimums. Relying only on federal standards could lead to a facility operating in violation of more stringent state or local laws, resulting in penalties, operational disruptions, and reputational damage. Another incorrect approach would be to focus only on the most recently enacted federal regulation without verifying its applicability or superseding state/local rules. Environmental regulations are dynamic, and while new federal rules may be introduced, they may not automatically override existing, more stringent state or local requirements. An auditor must confirm the current status and applicability of all relevant regulations. A third incorrect approach would be to assume that compliance with the permitting process automatically guarantees adherence to all air quality standards. While permits are a critical component of compliance, they are based on the regulations in effect at the time of issuance and may not reflect subsequent regulatory changes or the most stringent applicable standards. The auditor must independently verify that the permit conditions reflect the most current and stringent requirements. Professional reasoning. Environmental auditors should employ a systematic, multi-layered approach to regulatory assessment. This begins with identifying the primary federal statutes, e.g., CA, CWA, RCRA, TSCA, relevant to the facility's operations. Next, they must research and identify the specific state environmental agency regulations and any applicable local ordinances or rules that implement or supplement federal law. The core principle is to determine the most stringent requirement across all applicable governmental levels. This involves understanding the hierarchy of regulations and the concept that state and local rules can be more restrictive than federal ones. For permitting, auditors must verify that permit applications and conditions accurately reflect these most stringent requirements, and that ongoing compliance monitoring and reporting are aligned with all applicable standards. In cases of ambiguity or conflict, seeking clarification from regulatory agencies or legal counsel is a prudent step. This rigorous, multi-jurisdictional analysis ensures a comprehensive and accurate environmental compliance assessment, which is the hallmark of professional practice. Question 14. When evaluating the effectiveness of a wastewater treatment facility's compliance with UK surface water quality standards, which approach best demonstrates a certified environmental auditor's commitment to best professional practice and proactive environmental stewardship? Option A. Verifying that the facility's operational costs for wastewater treatment are within the industry average for similar facilities. Option B. Reviewing the facility's discharge monitoring reports to confirm adherence to current permit parameters and identifying any historical exceedances that have been addressed. Option C. Confirming that the facility has implemented a basic stormwater management plan as required by general environmental guidelines. Option D. Assessing the facility's current treatment technologies against the latest available scientific literature on emerging contaminants and projecting potential future regulatory tightening of discharge limits for key parameters. The correct answer is B. Reviewing the facility's discharge monitoring reports to confirm adherence to current permit parameters and identifying any historical exceedances that have been addressed. Explanation. Scenario analysis. This scenario presents a common challenge for certified environmental auditors, assessing the effectiveness of a wastewater treatment system against evolving regulatory standards and best practices. The challenge lies in moving beyond a simple compliance check to a proactive evaluation of system resilience and future-proofing. Auditors must consider not only current permit limits, but also potential future stricter standards, the impact of climate change on water availability and discharge quality, and the integration of advanced monitoring technologies. The complexity arises from balancing cost-effectiveness with environmental protection and ensuring the chosen technologies are appropriate for the specific wastewater characteristics and receiving water body. Correct approach analysis. The best professional practice involves a comprehensive evaluation that considers the current operational performance against existing discharge permits, while also projecting future regulatory trends and environmental conditions. This includes assessing the technological suitability of the current treatment processes, identifying potential upgrade pathways, and evaluating the robustness of the monitoring program to detect subtle changes or emerging contaminants. A key element is the proactive identification of non-compliance risks and the recommendation of preventative measures, aligning with the principles of continuous improvement and due diligence inherent in environmental auditing. This approach ensures the client is not only compliant today, but also prepared for future environmental challenges and regulatory shifts, demonstrating a commitment to long-term environmental stewardship. Incorrect approaches analysis. Focusing solely on meeting current permit limits without considering future regulatory changes or emerging contaminants represents a failure in proactive risk management and best practice. This approach is reactive and may lead to costly retrofits or non-compliance when standards are updated. It also overlooks the auditor's ethical responsibility to advise on best available techniques and long-term sustainability. Evaluating the system based only on the capital cost of existing technology, without a thorough assessment of its operational efficiency, environmental performance, or adaptability to future needs, is a significant professional failing. This prioritizes short-term financial considerations over environmental protection and long-term operational effectiveness, potentially leading to suboptimal environmental outcomes and increased life cycle costs. Recommending technology upgrades based on anecdotal evidence or industry buzzwords, without a rigorous technical and environmental performance assessment tailored to the specific site conditions and wastewater characteristics, is unprofessional and potentially detrimental. This approach lacks scientific rigor and may result in the implementation of ineffective or inappropriate solutions, wasting resources and failing to achieve desired environmental improvements. Professional reasoning. Certified environmental auditors must adopt a holistic and forward-looking approach. This involves understanding the client's operational context, the specific regulatory landscape, e.g., UK environmental regulations concerning water quality, and the broader environmental challenges. The decision-making process should prioritize a risk-based assessment, identifying areas of potential noncompliance or suboptimal performance. Auditors should then recommend practical, technically sound, and cost-effective solutions that not only ensure current compliance, but also enhance environmental performance and resilience for the future. This requires a deep understanding of wastewater treatment technologies, monitoring techniques, and relevant environmental legislation, coupled with strong analytical and communication skills to effectively advise stakeholders. Question 15. Cost-benefit analysis shows that a comprehensive, detailed environmental aspects and impacts register for every single minor process within a large manufacturing facility would be resource-intensive to develop and maintain. However, the certified environmental auditor is tasked with evaluating the facility's ISO 14001 Environmental Management System (EMS) implementation. Which approach to assessing the environmental aspects and impacts register would best demonstrate adherence to the spirit and requirements of ISO 14001 while remaining practically implementable. Option A. The auditor should approve a register that relies solely on historical environmental data and permits, without requiring an assessment of new processes or potential future operational changes. Option B. The auditor should accept a register that focuses primarily on aspects with direct cost-saving potential, as this aligns with the initial cost-benefit analysis and ensures financial viability of the EMS. Option C. The auditor should insist on a complete register of all conceivable environmental aspects, regardless of their perceived significance, to ensure no potential environmental issue is overlooked, even if it requires extensive resources. Option D. The auditor should verify that the EMS prioritizes the identification and assessment of significant environmental aspects based on established criteria, and that objectives and targets are developed for these significant aspects, with a plan for addressing less significant aspects over time. The correct answer is D. The auditor should verify that the EMS prioritizes the identification and assessment of significant environmental aspects based on established criteria, and that objectives and targets are developed for these significant aspects, with a plan for addressing less significant aspects over time. Explanation. This scenario presents a common challenge in implementing an environmental management system, EMS, based on ISO 14001, particularly concerning the integration of environmental aspects and impacts analysis with operational realities and resource constraints. The professional challenge lies in balancing the rigorous requirements of the standard with the practical limitations of a manufacturing facility, ensuring that the EMS is both effective and sustainable. The need for deep analysis stems from the potential for superficial implementation, which can lead to non-compliance, missed opportunities for improvement, and ultimately, a failure to achieve the intended environmental benefits. The correct approach, which involves a phased implementation of the environmental aspects and impacts analysis, prioritizing significant aspects, and developing targeted objectives and targets, represents best professional practice. This aligns with the principles of ISO 14001, which emphasizes a risk-based approach and the need for practical, achievable environmental objectives. By focusing on significant aspects first, auditors ensure that the most critical environmental risks are addressed, leading to a more efficient and effective use of resources. This also demonstrates a commitment to continual improvement, a core tenet of the standard. Ethically, this approach ensures that the organization is genuinely striving to manage its environmental performance, rather than merely creating a paper-based system. An incorrect approach that focuses solely on identifying all potential aspects without a clear prioritization strategy fails to address the practicalities of implementation. This can lead to an overwhelming amount of data, making it difficult to establish meaningful objectives and targets, and potentially diluting efforts on the most critical environmental issues. This approach risks superficial compliance, where numerous minor aspects are documented but significant ones are not adequately managed, leading to potential regulatory breaches and environmental harm. Another incorrect approach that prioritizes cost reduction over the thorough identification and assessment of environmental aspects and impacts is ethically unsound and likely to lead to non-compliance. Environmental regulations and the ISO 14001 standard require a comprehensive understanding of an organization's environmental footprint. Cutting corners on this fundamental step to save money undermines the purpose of an EMS and can result in significant environmental damage, fines, and reputational damage. This approach demonstrates a lack of commitment to environmental responsibility. A further incorrect approach that relies solely on historical data without considering new processes or potential future impacts neglects the dynamic nature of environmental management. ISO 14001 requires an organization to consider its current and planned activities. Failing to do so can lead to unforeseen environmental issues and non-compliance with evolving regulations. This approach is reactive rather than proactive, hindering the goal of continual environmental improvement. A professional decision-making process for similar situations should involve a thorough understanding of the ISO 14001 standards requirements, a realistic assessment of the organization's resources and operational context, and a commitment to a risk-based, phased approach to implementation. Auditors should engage with operational staff to gain a practical understanding of processes and potential environmental interaction. Prioritization of significant aspects should be a key focus, ensuring that efforts are directed towards areas with the greatest potential for environmental impact and improvement. Regular review and adaptation of the EMS are crucial to ensure its ongoing effectiveness and compliance. Question 16. Risk assessment procedures indicate a potential for legacy soil contamination at an industrial site due to historical operations, but the client, a property developer, is eager to proceed with redevelopment and requests a minimal investigation to expedite the process, citing a lack of visible evidence of spills. As a certified environmental auditor, what is the most appropriate course of action? Option A. Recommend a limited, visual-only inspection and superficial soil sampling in easily accessible areas, prioritizing the client's desire for a quick and cost-effective assessment. Option B. Advise the client that a full investigation is likely to be costly and time-consuming, and suggest focusing only on areas where contamination is most probable based on anecdotal information, rather than a systematic approach. Option C. Rely on the client's assurance of no historical spills and the absence of visible evidence to conclude that further investigation is unnecessary, proceeding with a simplified report. Option D. Conduct a comprehensive site investigation, including intrusive sampling and analysis, to thoroughly assess the potential for contamination, and report all findings accurately and transparently to the client and relevant regulatory bodies as required. The correct answer is D. Conduct a comprehensive site investigation, including intrusive sampling and analysis, to thoroughly assess the potential for contamination, and report all findings accurately and transparently to the client and relevant regulatory bodies as required. Explanation. Scenario analysis. This scenario presents a professional challenge for a certified environmental auditor due to the inherent conflict between immediate economic pressures and long-term environmental stewardship, particularly concerning a potentially overlooked legacy contamination issue. The auditor must navigate the ethical imperative to report findings accurately and comprehensively, even when such reporting may have significant financial implications for the client. The pressure to downplay or delay reporting, especially when the contamination is not immediately obvious or its full extent is uncertain, requires a robust understanding of regulatory obligations and ethical principles. Correct approach analysis. The correct approach involves a thorough, science-based investigation and transparent reporting of all findings, regardless of potential negative consequences for the client. This aligns with the core ethical duty of an auditor to uphold professional integrity and public trust. Specifically, it adheres to the principles of environmental due diligence, which mandate the identification and assessment of environmental liabilities. Regulatory frameworks for environmental auditing, such as those governing contaminated land assessment and reporting, require a proactive and honest disclosure of potential risks. Failing to fully investigate and report a plausible contamination scenario would violate professional standards and potentially expose the auditor to liability. Incorrect approaches analysis. One incorrect approach involves relying solely on readily available visual evidence and dismissing the possibility of subsurface contamination without further investigation. This fails to meet the standard of professional care expected of an environmental auditor. Regulatory requirements for site assessments often mandate intrusive investigations, e.g., soil sampling, groundwater monitoring, to identify potential contamination that is not visually apparent. Ethically, this approach prioritizes expediency over thoroughness, potentially leading to undisclosed environmental liabilities. Another incorrect approach is to accept the client's assurance that no historical records of hazardous material use exist without independent verification. Environmental auditors have a responsibility to conduct their own due diligence, which includes reviewing historical site records, regulatory databases, and conducting interviews. Relying solely on client assurances, especially when there are indicators of potential concern, is a failure of professional skepticism and due diligence. This can lead to a misrepresentation of the environmental condition of the site, violating regulatory reporting requirements and ethical obligations. A third incorrect approach is to recommend a minimal, superficial investigation based on the client's desire to minimize costs, even when the initial risk assessment suggests a higher probability of contamination. This compromises the auditor's independence and objectivity. Environmental auditors must act in the public interest and adhere to scientific principles, not client budget constraints when determining the scope of necessary investigations. This approach violates the fundamental ethical principle of acting with integrity and competence, and it fails to meet the regulatory standard for environmental site assessments. Professional reasoning. Professionals should adopt a systematic approach that begins with a comprehensive understanding of the regulatory framework governing environmental auditing and site assessment in the relevant jurisdiction. This includes identifying all applicable laws, regulations, and professional guidelines. The auditor must then apply scientific principles to the assessment, employing appropriate methodologies for data collection and analysis. Ethical considerations, such as integrity, objectivity, and professional competence, must guide every step of the process. When faced with conflicting pressures, such as client cost concerns versus the need for thorough investigation, the auditor must prioritize regulatory compliance and ethical obligations. A robust professional decision-making process involves 1. Clearly defining the scope of work based on regulatory requirements and initial risk assessment. 2. Conducting a thorough and unbiased investigation. 3. Transparently documenting all findings and methodologies. 4. Communicating all significant findings and potential risks to the client and relevant authorities as required by law. And 5. Maintaining professional skepticism and independence throughout the engagement. Question 17. The efficiency study reveals a significant increase in hazardous waste generation at a manufacturing facility. As a certified environmental auditor, which of the following strategies would represent the most effective and compliant approach to address this issue, considering the principles of waste management and pollution prevention? Option A. Implement a comprehensive waste audit to identify opportunities for source reduction and cleaner production methods within the manufacturing processes. Option B. Establish a broad, facility-wide recycling program without detailed waste stream characterization. Option C. Focus on investing in advanced end-of-pipe treatment technologies to process the increased volume of hazardous waste. Option D. Increase the frequency of hazardous waste disposal and explore options for expanding existing landfill capacity. Correct answer is A. Implement a comprehensive waste audit to identify opportunities for source reduction and cleaner production methods within the manufacturing processes. Explanation. The efficiency study reveals a significant increase in hazardous waste generation at a manufacturing facility. This scenario is professionally challenging because the certified environmental auditor must balance the economic pressures of production with stringent regulatory compliance and the ethical imperative to prevent pollution and protect human health and the environment. The auditor needs to critically assess the effectiveness of current waste management practices, identify root causes of increased generation, and propose sustainable solutions that are both environmentally sound and economically viable. The correct approach involves a comprehensive waste audit focusing on source reduction and cleaner production methods. This aligns with the principles of pollution prevention and waste minimization, which are prioritized in environmental regulations. By investigating the processes upstream of waste generation, the auditor can identify opportunities to redesign processes, substitute hazardous materials with less harmful alternatives, and improve operational efficiencies. This proactive strategy not only reduces the volume and hazard of waste, but also often leads to cost savings through reduced material consumption and disposal fees. It directly addresses the regulatory requirement to manage waste in a manner that minimizes environmental impact and adheres to the waste hierarchy: prevention, reuse, recycling, recovery, disposal. Ethically, this approach demonstrates a commitment to environmental stewardship and corporate social responsibility. An incorrect approach would be to solely focus on end-of-pipe treatment technologies, such as increased incineration or advanced hazardous waste treatment, without first exploring minimization. While these technologies are necessary for managing unavoidable waste, prioritizing them over source reduction is often less effective and more costly in the long run. Regulations typically mandate exploring minimization options before relying on treatment and disposal. Ethically, this approach can be seen as a failure to adopt the most responsible and sustainable waste management practices, potentially leading to continued environmental burden and higher long-term liabilities. Another incorrect approach would be to recommend simply increasing landfill capacity or frequency of disposal. This is environmentally irresponsible and often legally prohibited for hazardous waste, as landfilling is the least preferred option in the waste hierarchy. Regulations strictly control landfill design and operation for hazardous waste, and simply increasing capacity without addressing the generation source is a failure to comply with the spirit and letter of waste management laws, which emphasize reduction and treatment. Ethically, this represents a disregard for long-term environmental protection and potential future contamination. A further incorrect approach might be to suggest a broad, unspecific recycling program without a thorough characterization of the waste streams. While recycling is a valuable waste management technique, its effectiveness depends on accurate waste identification and segregation. Implementing a generic program without understanding the specific waste components and their recyclability can lead to contamination, increased costs, and ultimately, failure to divert significant amounts of waste from disposal. This can also lead to non-compliance if hazardous waste is improperly mixed with recyclable materials, violating specific hazardous waste handling regulations. The professional decision-making process for similar situations should begin with a thorough understanding of the applicable regulatory framework, including waste characterization requirements, the waste hierarchy, and specific mandates for pollution prevention. The auditor should then conduct a detailed waste audit, systematically examining each stage of the production process to identify opportunities for source reduction and cleaner production. This involves engaging with operational staff, reviewing process data, and understanding material inputs and outputs. Based on this analysis, the auditor should develop a prioritized list of recommendations, starting with the most effective and sustainable options, and then consider appropriate treatment and disposal methods for any residual waste. Communication with stakeholders, including management and regulatory bodies, is crucial throughout the process to ensure buy-in and compliance. Question 18. The efficiency study reveals a 25% increase in hazardous waste generation over the past quarter at a chemical processing plant. As a certified environmental auditor, which of the following stakeholder-centric actions would best address this issue while ensuring regulatory compliance and promoting long-term sustainability? Option A. Focus solely on negotiating a lower disposal rate with the current waste contractor, assuming the increased generation is an unavoidable consequence of production demands. Option B. Immediately recommend a significant reduction in production output to curb waste generation, without consulting operational teams or exploring alternative waste reduction technologies. Option C. Convene a working group comprising production managers, environmental health and safety A's, personnel, and representatives from the waste disposal contractor to analyze the waste streams, identify sources of increased generation, and collaboratively develop a revised waste minimization plan, including potential process modifications and employee training. Option D. Propose the outsourcing of waste management to a new, less experienced contractor who offers a lower per-unit disposal cost, without conducting a thorough due diligence on their environmental performance or compliance history. The correct answer is C. Convene a working group comprising production managers, environmental health and safety A's, personnel, and representatives from the waste disposal contractor to analyze the waste streams, identify sources of increased generation, and collaboratively develop a revised waste minimization plan, including potential process modifications and employee training. Explanation. The efficiency study reveals a significant increase in waste generation at a manufacturing facility, directly impacting its environmental performance metrics. This scenario is professionally challenging because it requires the certified environmental auditor to balance the company's operational efficiency goals with its environmental compliance obligations and stakeholder expectations. The auditor must not only identify the root cause of the increased waste, but also propose solutions that are both environmentally sound and economically viable, considering the diverse interests of various stakeholders. The correct approach involves engaging with all relevant stakeholders, including operational management, environmental compliance officers, and potentially community representatives or regulatory bodies, to collaboratively develop and implement a waste reduction strategy. This approach represents best professional practice because it aligns with the principles of environmental management systems, e.g., ISO 14001, which emphasize stakeholder engagement and continuous improvement. It also adheres to the ethical duty of an auditor to ensure transparency, fairness, and the effective management of environmental risks, thereby fostering trust and promoting sustainable practices. An incorrect approach would be to solely focus on the financial implications of the increased waste without adequately addressing the environmental impact or consulting with affected parties. This could lead to short-sighted solutions that might reduce immediate costs but exacerbate long-term environmental problems or alienate stakeholders. Another incorrect approach would be to recommend drastic operational changes without a thorough understanding of their feasibility or impact on other aspects of the business, potentially leading to resistance and failure of implementation. Ethically, ignoring stakeholder concerns or failing to consider the full environmental implications constitutes a dereliction of professional duty. Professionals should employ a decision-making framework that begins with a comprehensive assessment of the situation, including data analysis and root cause identification. This should be followed by a stakeholder analysis to understand their perspectives, concerns, and potential influence. Subsequently, a range of potential solutions should be evaluated based on their environmental effectiveness, economic feasibility, social acceptability, and regulatory compliance. The chosen solution should be developed collaboratively with key stakeholders and integrated into the organization's environmental management system, with clear monitoring and reporting mechanisms established to track progress and ensure accountability. Question 19. The assessment process reveals that during a compliance audit of a manufacturing facility, the audit team discovers preliminary evidence suggesting a potential breach of wastewater discharge limits based on a single, unconfirmed sample reading. The audit schedule is tight, and further sampling and laboratory analysis would require significant additional time and resources, potentially delaying the audit report. The lead auditor must decide how to proceed. Option A. Immediately halt the audit and demand extensive, immediate resampling and laboratory analysis of all wastewater discharge points, regardless of the impact on the audit schedule and budget. Option B. Include the preliminary finding as a confirmed noncompliance in the audit report, assuming the single sample is representative of a systemic issue, to ensure the auditee is alerted to the severity of the situation. Option C. Ignore the preliminary finding due to the tight schedule and the unconfirmed nature of the sample, focusing solely on documented evidence that is readily available and confirmed. Option D. Document the preliminary finding as a potential noncompliance, clearly stating its unconfirmed nature, and recommend a follow-up audit or specific testing by the auditee to verify the discharge levels, while proceeding with the rest of the audit as planned. Correct answer is D. Document the preliminary finding as a potential noncompliance, clearly stating its unconfirmed nature, and recommend a follow-up audit or specific testing by the auditee to verify the discharge levels, while proceeding with the rest of the audit as planned. Explanation. The assessment process reveals a common challenge in environmental auditing, balancing the need for thoroughness with practical constraints. The scenario presents a situation where an auditor must decide how to proceed when initial evidence suggests a potential noncompliance, but further investigation is resource-intensive. This requires a professional judgment that aligns with auditing principles, regulatory requirements, and ethical obligations. The correct approach prioritizes the auditor's responsibility to gather sufficient appropriate evidence to support their findings and conclusions. This involves a systematic and objective evaluation of the environmental management system and its compliance with relevant regulations. Best professional practice dictates that when potential noncompliance is identified, the auditor must investigate further to confirm or refute the suspicion. This aligns with the core principles of auditing, such as due professional care, objectivity, and integrity, as outlined in standards like ISO 19011. The auditor's duty is to report accurately on the state of compliance, which necessitates a deeper dive when red flags appear, rather than making assumptions or dismissing potential issues due to time or cost pressures. An incorrect approach would be to dismiss the potential noncompliance without adequate investigation. This could stem from a desire to complete the audit quickly or to avoid reporting negative findings. Such an approach fails to uphold the auditor's professional responsibility to provide an accurate and reliable assessment. Ethically, it constitutes a breach of integrity and objectivity. Legally and regulatorily, it could lead to the issuance of an inaccurate audit report, potentially misleading stakeholders, and failing to identify risks that could result in future environmental damage or legal penalties for the auditee. Another incorrect approach might be to overemphasize the initial scope and refuse to deviate, even when compelling evidence suggests a broader issue. While scope adherence is important, professional auditors must exercise judgment to address significant emerging issues that fall within the general objectives of the audit, especially when they relate to compliance. This rigid adherence can be seen as a failure of due professional care. The professional reasoning framework for such situations involves a risk-based approach. Auditors should first assess the significance of the potential noncompliance. If it appears material, they should then consider the resources required for further investigation against the potential impact of the noncompliance. Communication with the auditee and the audit sponsor is crucial to manage expectations and potentially adjust resources or scope if necessary. The ultimate decision must be guided by the auditor's professional judgment, ensuring that the audit objectives are met and that the findings are robust and defensible. Question 20. Quality control measures reveal that a manufacturing facility's air quality management system appears to be operating within the parameters of its current air quality permit. However, an auditor is tasked with assessing the facility's preparedness for evolving climate change regulations and the accuracy of its greenhouse gas (GHG) emissions inventory. Which approach best addresses this audit objective? Option A. Focus on verifying the operational efficiency of the facility's existing scrubbers and filters to ensure they are meeting their design specifications for particulate matter and sulfur dioxide removal, as these are the primary pollutants listed in the current permit. Option B. Perform a superficial review of the facility's environmental policy statement to confirm a general commitment to environmental protection, without delving into specific emission control technologies or inventory methodologies. Option C. Conduct a detailed review of the facility's GHG emissions inventory methodology. Compare it against current and anticipated regulatory reporting requirements for GHG emissions, and evaluate the facility's documented climate change mitigation strategies for their alignment with industry best practices and potential future carbon pricing mechanisms. Option D. Rely on the historical air emission inventory data submitted by the facility over the past 5 years, assuming its accuracy, and confirm that the facility is adhering to the monitoring frequencies stipulated in its existing air quality permit. The correct answer is C. Conduct a detailed review of the facility's GHG emissions inventory methodology. Compare it against current and anticipated regulatory reporting requirements for GHG emissions, and evaluate the facility's documented climate change mitigation strategies for their alignment with industry best practices and potential future carbon pricing mechanisms. Explanation. Scenario analysis. This scenario is professionally challenging because it requires an environmental auditor to balance the immediate need for operational continuity with the long-term imperative of regulatory compliance and environmental protection. The auditor must critically assess the effectiveness of existing controls against evolving regulatory standards and potential future liabilities, particularly concerning greenhouse gas (GHG) emissions, which are subject to increasing scrutiny and potential carbon pricing mechanisms. The auditor's judgment is crucial in determining whether the current monitoring and reporting practices are sufficient to meet the stringent requirements of air quality permitting and climate change mitigation strategies. Correct approach analysis. The correct approach represents best professional practice because it prioritizes a comprehensive review of the facility's air quality management system, specifically focusing on the adequacy of its GHG emissions inventory and the alignment of its climate change mitigation strategies with current and anticipated regulatory frameworks. This approach demonstrates due diligence by proactively identifying potential noncompliance issues related to GHG emissions, which are a key component of modern air quality regulations and climate change policies. It ensures that the facility is not only meeting current permit conditions, but also preparing for future regulatory developments, thereby minimizing environmental risk and potential penalties. This aligns with the ethical obligation of an auditor to provide an objective and thorough assessment that safeguards both the environment and the client's long-term interests. Incorrect approaches analysis. One incorrect approach fails by focusing solely on meeting the minimum requirements of the existing air quality permit, without considering the evolving nature of GHG regulations and climate change mitigation strategies. This approach is professionally unacceptable because it ignores the proactive element of environmental auditing, which should anticipate future regulatory changes and potential liabilities. It represents a failure to uphold the auditor's responsibility to identify emerging risks and advise on best practices beyond the immediate compliance horizon, potentially leading to future noncompliance and significant financial penalties. Another incorrect approach is flawed by concentrating exclusively on the operational efficiency of existing air pollution control technologies, e.g., scrubbers, filters, without a thorough evaluation of their effectiveness in controlling all regulated air pollutants, including GHGs, or their alignment with current emission standards. This approach is professionally deficient, as it overlooks the broader scope of air quality management, which encompasses not just the technology itself, but also its performance relative to regulatory limits and the completeness of emission reporting. It risks missing critical noncompliance issues related to specific pollutants or inadequate control of fugitive emissions, thereby failing to provide a comprehensive assessment. A further incorrect approach is problematic by solely relying on historical air emission inventory data without verifying its accuracy or assessing its relevance to current operational conditions and regulatory requirements. This approach is professionally unacceptable because it assumes past data is inherently accurate and sufficient for present-day compliance and future planning. It fails to account for potential changes in production processes, raw materials, or control technology performance that could significantly alter emission profiles. This can lead to inaccurate compliance assessments and a failure to identify actual emission exceedances or reporting discrepancies. Professional reasoning. Professionals should employ a decision-making framework that begins with understanding the specific regulatory jurisdiction's requirements for air quality management, including permitting, monitoring, and reporting. This involves a systematic review of all relevant legislation, standards, and guidance documents. The auditor should then assess the facility's current practices against these requirements, focusing on areas of potential risk such as GHG emissions, mobile and industrial source emissions, and the effectiveness of control technologies. A critical step is to evaluate the robustness of the monitoring and data management systems to ensure the accuracy and reliability of emission inventories. The decision-making process should involve a risk-based approach, prioritizing areas with the highest potential for noncompliance or environmental impact. Finally, the auditor must communicate findings clearly and provide actionable recommendations that enable the client to achieve and maintain compliance, while also adopting best practices for environmental stewardship.